You can hear the drinking sound. Wait, sorry, I have to drink water before I start talking. Sorry, I'm not fasting. Okay, so basically you have these two books for those who already catch it. Okay, hence, okay, delivered by Shear, and also by postage. Maybe within these 2 weeks you will get it. Depends on where is the area and the post, how fast they process lah. Okay, so these two books. So I suggest you to mark it. So where is the Eurocode? So for Eurocode 0, this one you have Eurocode 0, Eurocode 1, and the MS1553. This one you are not only using for this class. You will use it like for the next class, the reinforced concrete design also. So I like to mark it, okay, Eurocode 0, 1, and then the annex. Okay, the annex is where you will get all the tables. So you can go through the Eurocode by yourself, and then you mark where you need to use. Like you need to get the wind load, the annex, okay, the GK, QK value, all are here. Okay. Oh, my webcam is not giving me cooperation today. Why is keep kicking me out? What's wrong? Wait, okay. But now it's changed to using my laptop camera. Okay, another camera. I have two cameras. Okay, so this one, another one, Eurocode 2, where we are going to use a lot also. It's blinking. Okay, this is the bad thing when we use internet for class. Sometimes it's just like to disappear. Can you see my webcam? Blinking.
Rosak. Blinking.
Blinking, eh? Wait a minute, It's changing to this one. Okay, so this is a Eurocode 2, and today we will go to behind table 5.5. Where is at the behind there? Now it come another this one. So it's okay. Later I will show you where to find it. Okay. So let's start our class today. Today we will go through two things. Okay. First is this one. So let me start the PowerPoint. For all this, actually, I have prepared the video, YouTube video, which is a shorter one. So because during the class recording, we will take times. But for the recording, it's like very short and more compressed. So you can also refer to the YouTube video for your revisions. Because on 7 May, you will have the test one already. Okay, so... wait, display setting, okay. Okay, so first we need to go through this preliminary beam size. So means that how you estimate your beam size. Okay, so beam size is like you need to determine, you need to design for the B and the hash. Okay, so how you determine this size at the early stage when you want to do design. Okay, so you need to start. Okay, let me get the laser pointer. Okay, so you need to start. Okay, then you will start with beam length in L. So after this slide, we will have an example, don't worry. So let's say this is a 5 meter length beam you want to design. Okay, you only know the length size, means the span distance. Okay, so you need to design by yourself the value of B and hash. So we have some guidance to estimate the hash. Okay, So this is just a guidance for you to do. So normally the L over H is 13 to 18. So you can either take the middle value like 14, 15. It's okay.
Doctor, you're not sharing your screen.
Oh, I forgot already. Yeah, you see. Luckily you tell me. Wait, let me share it. You see the webcam lah, make me. Wait, so let me get started again. I thought I shared already. Yeah. Sorry, is it started? Not yet. You are presenting your screen coming up. I forgot it. Okay, sorry. So let me start again. Everyone can see this slide?
Yes.
Okay, so first you get the beam size. The span is 5 meters, example. Okay, so you need to design the B and the H. For your project, you need to do it also. You need to estimate all your own beam size and so on. Okay, so use the beam length in millimeter. Okay, and then to estimate the H. So L over H, normally we use in between 13 to 18. It's acceptable. Okay, this is just a guidance for you guys to estimate it. You can take either 14 or 15 in the middle, get the value. And then you have the L, you have the range. Maybe you can put 14 or 15. Later you will have one example after this. Okay, so you can get the H because only one unknown, right? Okay, so after you get the H, to estimate the B over H is 0.3 to 0.5. So you can get in between the middle value 0.5, 6. Okay, then you will get the value of B and H. And then you check the B value. The B value must be complied B minimum from table 5.5 EN 1992 Eurocode 2 lah, 11, table 5.5 or 5.6. So this is in the Eurocode 2. You can go to the, okay, the back section if you can find it. So everyone, you can try to open it here. This is at the back after the table added from BS8110. It's at the back. It's at the back. It's not at the front. It's at the appendix at the back. Okay, it's that this section is quite far away. So table 5.5 and 5.6. So those you are using the soft copy, you can open this also. Okay. So everyone, can you try to find it? Once you find it, you can raise up your hand and then you can tell me, because later we need to use this. So everyone, you can take out your Eurocode and take a look at the table 5.5 and 5.6. Can everyone, you find out the Eurocode? Have you find the Eurocode? The table 5.5 and 5.6. I like to do marking as just a marking here. So when I want to find it, I don't need to go through it. I just look at the marking, then I know where should I find. Also the diameter and so on, the cross section. So you can do marking, easier for you. Okay. And have you find are you doing what I'm saying now? Because no response, there's no webcam also.
Yes, sir.
Okay, I hope you will find it, because to find out where is it is important also. You need to know how to use the Eurocode. Okay, so okay, must comply with minimum. B minimum for table 5.5 or 5.6. Okay, so 5.5 is for the simply supported beam and 5.6 is for the continuous beam. So you need to use, if the value is greater than the 5.6 at the minimum B minimum, then you can use the estimated B. If not, then you need to choose the minimum value. Okay, so wait, we'll go to the next slide. Why is keep giving me this again? Okay. So this is the table. Everyone, can you find this table in your Eurocode? Make sure you have this, huh? Have you have this with you? If you want to take exam and what, you need to have this, test. and so on. Okay, so you can see that this is minimum dimension and exit distance for simply supported beam made with reinforced and pre-stressed concrete. And this is minimum dimension and exit distance for continuous beam. So this is for simply supported beam. This is for the continuous beam. Difference, simply supported beam mean only one span. Continuous is 2 span, 3 span or more. Okay, so this is the fire resistant. R 30 minutes, 60 minutes, 90 minutes, and so on. So you need to refer to this. So let's say you have an R60, okay, and then the possible combination of A and B mean where A is the average exit distance, B mean is this. So B minimum, let's say, wait. Okay, so B minimum here you can see here is 140, okay. So you need to get at least 120, sorry, 120. So the B mean is at least 120. Okay, you need to check how to use these two tables. So you go to next slide. So this is example. So can we go to this example? Are you ready?
Yes.
Okay,
Yeah,
so
doctor, I'm ready.
so determine the B and the hash of 5 meter simply supported beam. So now you have a simply supported beam with 5 meter. So you need to estimate the B and the hash. Okay. So to obtain hash, let's say we use L over hash is 14. So 5,000 over 14 is hash is 357.14 mm. Okay. 5,000 over hash is 14. So hash is equal to 5,000 over 14. So you will get hash equal to 357.14. This value. So to obtain the V value, let's say we use B over hash is 0.4. Let's say you use 0.4. Okay. So B over hash, okay, B over 357.14 is 0.4. So B is 142.85 mm. So once you get this value, you need to check whether it is greater than B minimum or smaller than B minimum. So compare B with B minimum from table 5.5. Say duration of fire resistance is R60. So minimum is 120. So you go to this table. Okay. So first thing, you don't get the wrong table. Okay. Table 5.5 and 5.6. But then this one you see actually the B minimum is the same. Okay. B minimum for R30 is 80. Here is also 80. This is 120. This is 120. This is 150. This is 150. Same. Okay, R60 means you design the fire resistance can last for 60 minutes. Okay, so the B minimum is 120. Means your B minimum for the beam, okay, according to the fire resistant requirement, your beam size must be, the B must be greater than 120 at least. Cannot be lesser than that. Else it will not fulfill the requirement for this. Okay, so you can, so now the value is 142, is greater than 120, so can be used. So your B and H now is 142.85 and 357.14 mm. But this value, okay, you round it, okay, to a easier value because you want to design it later. If value like this is hard for you to calculate, and in the construction site, it's very difficult to construct so accurately. Like 142.85, hard to measure, right? So you round it to 150 times 360 mm. Okay? Everyone okay with this? So now let's say, everyone you try to calculate, I haven't calculated also. You try to use 15. This one you try to use 15. Okay, and then B over H you use 0.5. Sorry. This one you use 0.5. And then you calculate. So you will get the hash and you get the B. Can everyone calculate now and let me know? I haven't calculated also.
Alright, doktor.
You try to
Doktor,
calculate,
doktor nak tanya jap. Kalau contoh kan dia kata kalau nak buat yang L per H ni dia sama dengan 14 hingga 13 hingga 18 kan?
Yes.
Kalau untuk B dengan H ni pula dia di antara 0.3 hingga 0.8. Kalau yang atas tu kita buat contoh 16. Lepas tu yang bawah tu kita buat 0.3. Boleh ke?
You can do it. You can do it within the range is okay. But then you
Uh-huh.
need to check either the economic wise lah.
Oh.
You check, you make the big one, you make the small one, but all you can sustain the load for 2-story building, let's say. If cost wise you want a bigger beam or smaller beam.
Oh, mesti anak yang kecil.
So for design in practice, wait my slide is missing. So in practice, okay, you need to design economic one.
Oh, kalau dia punya bangunan tu kan jenisnya bangunan 3 story, agak-agak nak pakai beam kecil juga ke doktor?
Normally standard one lah, because it will keep distribute the load also. If your beam is too big, the column is too big also, the self weight will increase, right?
Ya, betul.
Okay, so you can check it first.
Oh, okay.
Okay, so you do it first. Let me write back here. You need to use. Here you need to use 0. Here you need to use 15. Here you try to use 0.5. So you can calculate the value. I need to go get my calculator. Wait a minute. I think some of your friends also being kicking out and join back the class, Internet not so good, I think everyone is here, right? Our student is 50, and then now it's 50, 51 is 52. So later I will complete the attendance. Okay, so let's say it's 15. So what value you will get? 5,000 divided by 15. Everyone, you get 333.33.
Yes.
Okay, so you get this one. 333.33. So B over 333.33 is 0.5. So B you will get how much? Times 0.5. You will get 166.67, right? So 166.67 is greater than 120, B mean. Then it's okay. Okay, so you will get 333.33 and 166.67. Okay, so you can round it out to become 170 times 350. You need to round it out. Don't put the value like this. But can you notice that when you use the greater, this is B, time hash, right? When B is here, hash is here. Okay. So when you have the greater B value, higher B value, the hash will be smaller. But when you use the B smaller, the hash will be higher. If you use this, okay, if you use this thing, okay, so you can take the value in the middle, so you will get the value also roughly similar at there, because it's not much different, right? 170 times 350 and 150 times 360. Try you get the area, you can see 170 times 350, so you will get 59500. So 150 times 360, you will get 54000. Okay, so this is the beam smaller size compared to this one, but then it's not much different, like a little bit only. Okay, so in terms of the cost, this one of course will save you more, isn't it? Because the area is smaller. Okay, so you are the designer, you can decide the beam size, but need to be within this range. So this range, okay, so the range of this and this is a guidance for you guys to design your beam. It's a guidance. Okay. So this is for the estimation, for the preliminary size lah. So any question for this?
No, doctor. Okay.
No, so also this slide already provided in the YouTube also. You can go through it if you want to have the revisions lah. So we will go to the chapter 3. So this one we will calculate a lot also. This is for the loading. So let me start it. Everyone, you have the slide already? You have this slide, right? I already upload in the classroom.
Yes,
last week. Okay. So also for chapter 3, I already also recorded the video in the YouTube. Okay, so you can go through it lah. Okay, so we will enter the chapter 3, which is the actions and load distribution. So your test 1 will until this chapter, and I think it's until what we learned today. So next week we are going to learn about the structure analysis for continuous beam. Okay, but that one normally won't be coming in the test because it's long, because you need to use a moment redistribution method. But that one you will need to use it in the project. So you need to study for your test until this chapter for test 1. Okay, so actions and load distribution. This slide is prepared by the IR Dr. Muhammad Sofi. Okay, he is the module this subject developer lah. Okay, he developed this subject. Okay, he is the IR also, our Sifu. Okay, so presented by me today. Okay, so actions, loads are primary consideration in any building. Let me get a laser. Okay, so it can be defined as external force that a building must resist to provide the reasonable performance, safety, and serviceability. Okay, you have the load, you remember the XLX and ULX. Okay, you need to differentiate that throughout the structure design working life. So the anticipated loads are influenced by buildings' intended use. Okay, occupancy and functions, configuration, size and shape, locations, climax, and site conditions. So ultimately, the types and magnitudes of design loads affect the critical decisions, okay? Such as material selections, construction details, architecture configurations. Thus, to optimize the values, performance versus economy of the finished product is essential to estimate the design load realistically. So first thing you need to design, you need to calculate the load. No load, how can you design it? Okay. So the load, okay, we will have few. So we will focus, for this subject, you will focus on the slab and the beam more. Okay, because we only learn until design the beam. Column, you will learn in the next subject lah. So for slab, now everyone, you know the slab, like you have the ground floor slab, first floor slab, rooftop, and so on. Okay, so the permanent action means the load is dead load, it's not going to change. It will be permanent there. So first is the self weight of slab. The load by the slab itself is also a loading. Okay, finishes and services. You have what finishes, the tile and so on. Okay, and ceiling. Let's say you are on the first floor, so you will have ceiling, right? Ceiling on the slab. Okay, so ceiling. And you will have variable actions. This is the life load. Then it's changeable. It's variable. Okay, depends on the function of the flow. So the unit is in kilonewton per meter square. Because square and slab is go for the area. You will have area. Okay. So it is in kilonewton per meter square. Okay, and then for beam, remember slab you need to be in meter square, and then slab is in kilonewton per meter length, according to the L. Okay, per meter length. So permanent action distribute from slab and roof. Okay, so the slab loading, okay, for permanent and variable action will distribute all to the beam nearby. Depends on where is the support. Okay, So slab, you will have one-way and two-way slab. Later we'll go through it, okay? So, and also the self-weight of beam, the weight from the beam itself. The dog next door, not my dog, not my dog, I don't have dog. You heard the barking? Okay, it stopped. Okay, and brick wall. So the beam on top of it, if you have brick wall, you need to calculate. Okay. Also, it will calculate according to kilonewton per meter lah. So we will have example. Don't worry, you will go through it. And variable action is distribution from the slab or roof. So the distribution from the actions, variable action is from this one. Okay, the variable action from the slab, you will distribute also the beam. So the beam will get the load from the slab. And the beam will distribute the load to the column. So for column, okay, you only have kilonewton. It will become point load. Okay, point load here. Permanent actions distribute from the beam and the self-weight of the column. Okay, variable action also distribute from the beam. So this is actually slab to the beam, and then beam will distribute to the column. And all the load from this will go through the foundation. It's also kilonewton. Permanent action distributes from column, self-weight of footing, and variable action also from the column. So if you get the wrong one at the slab, so you will bring it to the beam, also the wrong one. You bring it to the column, also the wrong one. You bring it to the foundation, also the wrong one. Okay? Next slide. My slide is, okay. So loading estimations, so permanent action of slab, for example, slab, self-weight of slab. So after this class, you need to have self-study time, and then you list out make the note for yourself, like how to calculate the permanent actions, the variable action for the slab, and so on. You can go through the examples, okay? So self-weight of slab is slab thickness, hash, times unit weight of concrete, RC, the concrete weight. 25 kilonewton per meter cube. Let's say this is the grade 25 concrete with 25 kilonewton per meter cube strength. Okay, so hash time 25 kilonewton per meter 3, you will get 25, you will get the meter square, right? Become meter square. As I said, slab is meter square. Okay, it's only an m power of 2. Okay, so in common practice, minimum slab thickness is 100. Okay, you use 100 or 150, between 100 to 150 lah, normally. So normally if you design for your project later on, also you can use in between 100 to 150. Okay, maximum slab span, short or long span is 36 hash. Okay, the thickness cannot, the span cannot be greater than 36 hash. Finishes depend on the floor finishes assigned by architecture. So you can refer to manufacturer catalog. So for example, for the ceramic tile, the size 600 mm times 600 mm, 4 pieces, and then one carton, the 1.44 meter square, you will get 31.68 kg. So ceramic tile, you get the kg times convert to Newton, divide by 1.44 meter square, you will get 0.22 per kilonewton per meter square. Okay, and then 30 mm thickness cement render. Okay, you convert the unit to the Newton, and then you times it. Okay, you will get the 0.56 kilonewton per meter square, and then total finishes load equal to ceramic tile add with the cement render, so you will get 0.78 kilonewton per meter square. And ceiling weight normally in the range of 0.30 to 0.5 kilonewton per meter square, depend on the ceiling type. Okay, so this is the value. Okay, so variable action on slab, what you can refer to, you can get it from the Eurocode 1 as shown in the table. Okay, characteristic variable actions, QK acting on the slab is caused by people, furniture, equipment, which is the variable in magnitude time dependence is considered. So example for variable action in EC1 are shown in the table. So where you get this QK, the small capital QK and the big QK, this is in kilonewton, and this is in kilonewton per meter square. So be careful, don't get the wrong one. Okay, for the slab, you need to get the kilonewton per meter square. So where you can get this? It's already mentioned in Eurocode 1. So you can get out the book of the Eurocode 0 and Eurocode 1. And it is at the back sections, at the Malaysia, at the annex section. Okay, it's at the Malaysia Standard, the National Annex. You can go to the back side. Okay, it's at after the Eurocode 1 and 2 is at the behind there. Okay, then you can go to the page 7. Everyone, can you find this table? If you have the Eurocode, you can find the table. You can find this table. Can everyone find this table? I just want to show you where you can get all this value. Okay. So for those you get it is supposedly the Standard Malaysia 2010, the Mr. Code, the prepared this hard copy already included everything you need. All the tables are here. That's why I say you better get the hard copy because all are here. You don't need to get hectic yourself to print it out and then arrange it. This is easier. Okay, and then you can keep it until you work and so on. So everyone, can you get this? Are you with me? Okay. Here they click it, and then before that they have the table mention what is the A1, A2, A3, A4, A5, until everything. They have the QK and GK. Semua dapat kan? Anyone can answer me? If you find it, can you raise your hand? You have a raise hand button, right? So I can know that. Have you guys found what I said here? You have this table. Can you find and locate the table?
Yes.
Okay. For design is open book test, open book. If you are attending the physical test and the exam, the only you can bring in is these two books, Eurocode 01 and Eurocode 2. Other than this, cannot. If you attend the physical test. Okay. So you need to find this. So it will explain to you what is A1, A2, A3, everything. And it will show you the value also. Okay. So this is the QK you need to get for the variable actions. For the permanent action, we will calculate. Okay, so this is all the value you can refer to. Okay, depends on what is the design you want to use for. You have shopping areas, you have area where people may congregate the exceptions of area defined under category A, B, D. You can see A is for the domestic and residential activities, B for office area. So different usage, you will have different QK. Okay, so this is why you need to use Eurocode. Okay, so loading estimation. Now we go to beam. Beam. Beam just now I mentioned is kilonewton per meter, right? Okay, beam is let me get the pen. So beam is kilonewton per meter. That's why unit weight of concrete is kilonewton per this kilonewton per meter cube. So the things you B times H, okay? So you can remove this, become 1. So you will get kilonewton per meter. That's why you are using B times H. Because the loadings from beam is per unit length. Okay, so later you will times the length when you calculate the total load, okay? So B and H, okay? Time the unit weight of concrete, then you will get the self weight of concrete per unit length, kilonewton per meter. For rectangular beam, you will use B times H, okay? Because this is not connected to the slab. This one normally used at the ground floor for those with non-suspended floor. Non-suspended floor means it's not connected to the slab. Or either if you have the rooftop, like the rooftop with only roof truss on it, you have no slab, then you are using the rectangular beam. So if you have the slab like this, is the beam together with the slab, like the ground floor with suspended floor, ground floor with suspended floor, or either first floor and so on. First floor, okay, the beam is connected to the slab. So the B here, the hash here, okay, you need to minus the hash F. This is the hash F. So basically you need to get this one. This is the hash you will use. You only calculate this part. That's why self-weight is BW. Okay, BW is this time hash minus hash F. So when the questions come out, you need to be careful. Either it is rectangular beam or either it is French beam. Difference, because this one you use the total hash, this one you use hash minus hash F. Both you will get the different answer. So if you get the wrong hash, then your calculation will be different. So make sure either the hash provided is hash W and is this hash or this hash. Okay, this is the thing you need to be careful. Either is rectangular beam or French beam. Okay. So the loading estimation, self-weight or column. Okay, self-weight or column is in kilonewton. Okay, because it will become point load, it will straight carry it like this. So all it will on the surface and then it will carry. That's why it become point load. So it's B times hash times length, and then times unit weight of concrete, kilonewton per meter square. Okay, so this is B, hash, and length. So the load from this column itself and the total load from the beam and so on, it will distribute to the foundation. So it is connected from the column, okay, and then to this foundation. That's why you will have the cell weight of footing. Footing, you need to take B times L. Where is going here? Wait. Wait a minute. Okay. So here you see, okay, B times L times T, thickness times unit weight. Okay. Because it's also point load here, you need to get the volume times the unit weight. And brick wall. Brick wall, it will give you normally 2.6 kilonewton per meter square. So you need to time the hash for the beam. It will go to the beam. Normally it will sit on the beam. So this is the beam. Okay, so this is the beam. Where's my PowerPoint? Wait a minute. Oh, my PowerPoint is hang. Wait, sorry, let me open it,
Tak apa, doktor, tak apa.
It's okay, wait for a minute. My internet. We'll go to example very soon, and it start to make problems. Wait.
Doktor, yang untuk kira-kira kolom semua tu, itu just menunjukkan je kan?
Wait a minute, guys.
Okay, dah done.
Okay, I'm back. Wait. Okay, so can you see my slide again?
Yes.
Okay, so we are back. Okay, so let me get the pen. Okay. So beam, brick wall will stay on the beam. So this is the beam. So normally it will give you the brick wall loading with 2.6 kilonewton per meter square. So you need to times wall height. Okay, you need to times the wall height. So you will get the unit for it according to this length. Okay, 2.6 times height, let's say it's 4 meter height. So 2.6 times h, then you will get the brick wall. Okay. So now we go to the loading distribution. Okay. So the loading distribution. Okay, so this one, laser pointer here, you follow me, distribution of action on slab. So this slab, you need to determine first is one-way slab or two-way slab. So now it's showing like this means it's one-way slab, means it's going to this direction, the left and right. It's not going to fall all four edges. Okay, so for example, the load from the slab and wall transfer to the beam. Okay, so this is the slab and here is the wall. The brick wall slab, the brick wall and the slab will transfer the load to the beam. So this is the beam, this is the beam, this is the beam. And then the beam will transfer the load. Why is keep doing this? Okay. Okay, the beam will transfer the load to the column. So this is the column. Okay. So the column here, the beam here will transfer the load to the column. So let's say here you have one column, you have one column. So it will take half. So half will go to here, half will go to here. Okay. So you will take the load if it is simply supported. Okay. So you will take this. So you will transfer to the column. So the column, okay, after this floor, here you will get more load also from another floor. Also transfer to the same column. So the column will get the load from each floor and then it will distribute to the foundation. So foundation normally it is sit on the hard rock area. That's why you have the piling, right? Like for Batu Pahat area, we are on the peak soil. So normally all the building we have the piling. So the piling will set on, it will be set until the set area, which is the hard rock area, to sustain the load from the building. Okay. So actions that apply on the beam may consist beam, self-weight, permanent and variable action from slab, action from secondary beam, and other structural, non-structural members supported by the beam. So do you understand what is secondary beam? Secondary beam means normally beam we will connect to the column, right? But for secondary beams mean the secondary beam will transfer the load to the main beam. And then it will become point load at the main area, the main beam. So normally secondary beam is occurred at the toilet. Toilet the area is small and then it will have normally the beam size is small, like 150 times 450 only. The beam size is small because it is only for the small area. Okay, so you will have also secondary beam for your design, normally at the toilet area, and other structural or non-structural members supported by the beam. Okay, so the distribution of slab actions on beam depends on the slab dimensions, supporting system, and boundary condition. Also, boundary condition is important. Okay, it is important to determine the type of slab using the following criteria. So first, you need to determine either it is one-way slab or two-way slab. First step. Okay, so Ly and Lx. How you determine which one is Ly? How you determine which one is Lx? Ly is the greater value, the biggest, the value that is bigger. Let's say you have this is 3. Let's say you have a square. So here is 3. Here is 1 meter and 3 meter. So this one automatically you will pick it at Ly, and this is Lx. So let's say you have another slab. So this is 2, this is 3. As I said, the bigger value will become Ly, the smaller value will become Lx. So here is Ly, here is Lx. So Ly not necessary to be at this axis. It depends on the slab. Okay, which side is longer, the greater, the wider span, then that one is Ly. So Ly over Lx greater than 2.0 means it is only distribute to the Ly. The load from the slab, this area, will not distribute to the left and right, will not distribute to the Lx. Because it will distribute to the Ly. It become one-way slab. Only here supported it, one-way slab. You understand what I mean? Okay, for one-way slab means it's only distribute to 2 beams. Okay, for this beam and this beam. It will not distribute to 2 axes. No. But for two-way slab, Ly over Lx is less or equal to 2.0. Okay, so you will get Ly and Lx, and the value will distribute. Okay, Ly and then to Lx. So to calculate this distribution, we will have method. Okay, it's not like you simply divide by 4. No, because you need to depend on the beam size. Okay. So loading distribution, one-way spanning slab that's supported by the beam. Okay, so you can see A, B, C, D. So Lx here is the shorter span, Ly is the longer span. So the value is easy. If one-way slab is easy. W is 1/2 n Lx. Okay, it's just 0.5. If according to Eurocode, okay. So two-way slab panel freely supported along 4 edges. Freely supported along 4 edges, Okay, so you will have Ly at here, Lx at here. So you will distribute using this. So if it's at Ly, okay, this is for the Ly. You will use W equal to n Lx over 6 in the bracket 3 minus Ly over L6 power of 2. So this is very complicated, right? And for the Lx, it will be this, W equal to n Lx over 3. So for this is complicated. So we will have alternative method. Okay, so there are alternative methods. We consider various support condition and slab continuity. So later I will go through it. Okay, I explain to you the various support condition and slab continuity. Okay, the methods are slab shear coefficient from table 3.5 BS at 110. Now we are using Eurocode, but to calculate this loading distribution, we use this alternative method from the British standard. That one will simplify, and then it's easier compared to that equation you need to face. This equation is quite complicated, right? So to simplify it, we're using the BS at 110. So if you have the Eurocode, okay, you can go to the table. You can go to the table. It's the Eurocode 2. You find the Eurocode 2. It's at the behind section there. Just now you find the table 5.5, right? It is before that. You can find this table. Everyone, can you find this table? 3.14 and 3.15. Okay. Can you guys open it? There's mentioned table edited from BS8110. Can you find this? You find this first, so easier for you to check. You will use this a lot for your every time you need to check. Everyone, can you find this? For those you not check receipts, your hard copy, you can go to the soft copy lah. Okay, so I will explain to you from case 1 to case 9 according to the slab condition. Okay, so you have table 3.14 and 3.15. So this is using table 3.15. Okay, you go to table 3.15 in the BS Eurocode, the Eurocode 2 behind there, the behind one already attached a table here. Okay, if not, then you need to look at the screen lah. The screen here also showing. So can I go to each case now? I explain to you.
Yes, doctor.
Yes.
Okay. So for case 1, 4 edges, continuous edges. Here you need to be careful what thing is. Here, I show you. This is beta Vx. And this is beta Vy. Two different things. Normally, students careless at this thing. Let me go to the slide before. So you can see this. Okay? So you will have Ly and Lx, right? As I said, the Ly is the longest span. So Ly and Lx. To calculate Ly, you're using this. Where the longest span, Ly, you use beta Vx times n times Lx. But when you add Lx, you're using beta Vy. This is beta Vx. This is beta Vy. Two different things. You need to be careful. I noticed many times during the test, during the project submissions, students get confused with this, Vx and Vy. At longer span, you use Vx. At shorter span, you use Vy. Clear? Okay, so remember, Lx and Ly different. Okay, so for case 1, show 4 edges continue. So you can see this is the case 1. 4 edges continue means that surrounding case 1, all edges, okay, are continuous. Means the beams, the slab is continue. It has the slab at its surrounding. Can you see? All surrounding you will have slab. There's no void area. This is not at the edges. So this is case 1. For case 2, one short edges discontinue. So where is case 2? Let me remove all the. Okay, so for case 2, one short edge discontinue. So this is shorter edge, right? And here no span, right? No more slab. That's why it's one short edge discontinue. So one short edge discontinue. If you want to get the VBX, this is for X, this is for VBY. Okay, if you need the X, then you need to find the value. So you will get the value for L, and then you need to depend on Ly over Lx. You calculate Ly over Lx, right? So you need to refer either it is 1, 1.1, 1.2, and so on. So let's say it's 1.1, for example only. So it's case 2. So the value is this. And the VBY, the value is this. Yes, it depends on the value, the ratio of Ly over Lx. What if it is in the middle? Let's say it's 1.05 or 1.03. This is in the between, right? So you want to get the accurate one, you can use the what we call interpolate. Okay, you need to use the cross. I will show you later in the example. Okay, you need to calculate it. It's not like you simply take the value like that. Okay, later I will show you the hands-on example. So you need to get the value by using that method lah. Okay, later I show you. So number 3, let we go to number 3. One long edges discontinue. So for case 3, you can see it here is one long edges discontinue. Why is okay? So it's one long edges. Means the long edges one is the way the slab discontinue. So case 3 you can see it here. So the longer edge here is discontinue. No slab beside it. So this is case number 3. Okay, and then case 4, two adjacent edge discontinue. Case 4 is here. Adjacent edges is mean that it's side by side. You can see that this slab and these edges is discontinue. No slab here, no slab here. Okay, discontinue means no slab continue with it. So you need to refer to the value here if it is case 4. For case 5, two short edges discontinue. Two short edges mean at the LX, both LX, no slab. Here is void. This cross mean no slab, no slab. Here no slab also. That's why this is case 5. For case 6, two long edges discontinue. Here no slab. For at the LY, no slab. So you use case number 6. For case 7, okay, 3 edges discontinue. One long edge discontinue. Okay, so for case 6, where is 6? 6 is, 7. So long edge here, discontinue. Short edge, discontinue. And here short edge, continue. But then only one long edge is discontinue. So that's why you use case 7. For case 8, 3 edges discontinue and 1 short edge discontinue. 2 LY discontinue and 1 LX discontinue. Okay. So for case 9, 4 edges discontinue means surrounding it no more slab. So for the area, like for is let's say for the first floor, if you have staircase, so if you have staircase at that area, is considered no slab. I repeat, slab. No slab at the staircase area. Let's say here you have a staircase. So here is no slab. So when you calculate, you need to check. If let's say you need to design this one, this is the slab you needed. So you need to check. Here, if here is staircase, that means no slab. Staircase design is not covered in this chapter and is this subject also lah. So next subject maybe you will learn. So any question for this case 1 to case 9, you will have practice. So you will go through it. No questions? Can I go to next slide?
Setakat ni okey, doktor.
Okay, so you understand each case 1 to case 9, right? Depends on your type of slab, Okay, so let me go to the example. Okay, example 1, determine the characteristic, permanent and variable action on beam FB1 as shown in the above figure. For piece 1, a brick wall of 4 meters high is sitting on the beam. So unit weight of concrete is 25 kilonewton per meter cube. Finishes is 1.0 kilonewton per meter cube. Brick wall is 2.6 kilonewton per meter cube. Variable action is 4.0 kilonewton per meter cube. If in the class, I will ask you to sit down and then write this already. Okay, so you can look at this. So this is the FB1. You need to calculate FB1. Okay, and then you see this is the for precast slab is one-way slab. It is not two-way slab. Okay, precast slab always one way. Okay, so it will distribute the load to the FB1 here and FB1 here. So you will take half of it. Okay, and then this one, even this one, you can see that from this is the cross sections. So 4 meter height brick wall is sitting on it, and a slab, precast slab is sitting on it. And then this is the FB1 700 times 250. Okay, so the hash already given this one. So you no need to get the hash minus hash F for the French beam, because this is rectangular beam and precast slab. Precast slab, you understand precast? Precast means is in the factory is already being casted, being cast, and they're delivered to the build to the site for the assembly. It's considered as the IBS system. Okay, and then you need to get the QK and GK, which is the self-weight, brick wall, and slab for the dead load, for the permanent load, and the QK is from the slab for the variable actions. So this card, I want to open this PDF. Let me bring this. Okay, so I like my handwriting when I explain. So you can see this. This is what in the example one I already give you in the Google Classroom also. So what you have to do, everyone, can you see this? Is it big enough or you need me to zoom in?
Zoom sikit lagi, doktor.
Zoom sikit So this is the beam. Okay, this is the beam. You need to find the GK and QK now. And on the beam, the GK and QK, when you calculate everything, it will become uniform distributed load. Okay, so self-weight, brick wall, and slab is the GK, and QK is the slab. Okay, so first we calculate the permanent action first. So permanent actions, remember for the beam, you will be in per meter. Okay, so self-weight 0.425 times 0.7 B times hash, I already mentioned here, times 25 kilonewton per meter cube. This is the unit weight. You get 4.375 kilonewton per meter. And then brick wall is 2.6 kilonewton per meter. So the wall height is how much? It's 4 meter, right? It's already mentioned, right? So 2.6 times 4 meter, you get 10.4 kilonewton per meter. I like to write down the unit so I will not get confused or get mistake when I get the value. Okay, so for slab, okay, for slab, as I said, slab normally is in kilonewton per meter square. Okay, so later you calculate, you leave it in meter square first. So the thickness is 0.15, right? The slab thickness is 0.15, 150 mm, right? 0.15 times the unit weight, okay? Unit weight is 25 kilonewton per meter cube, time 1.0, the finishes. The finishes is the dead load, okay? So you will get 4.75 kilonewton per meter square. Okay, so this one, oh, this one is wrong. This one supposedly is kilonewton per meter. Sorry, I wrote the wrong one here, I think. The unit here is kilonewton per meter. So 4.75 kilonewton per meter square times 6/2 meter. Because just now the slab is one-way slab, right? So it will distribute half to this beam and half to this beam. That's why it's 6 meter divided by 2. Means 3 meter from here, the load will distribute to here, and another 3 will distribute to here. So that's why you will get 6/2, means half. Okay, you will get 14.25 kilo.
Doctor, can you repeat that one, 6/2? I cannot catch up. Sorry.
Wait, it's okay. So slow. Let me go to the this one. So you can this is the one-way slab, right? Means it will only distribute to one side. Means to FB1 at here and FB1 at here. The load will not go to the left, to the right. It will go to this beam and this beam only. One way. Because this precast slab is is one by one they make. So it is not, the load will not distribute to another slab beside it. So that's why you will become like this, become one piece. So it will only distribute to the beam here, FB1 here and FB1 here on this side. So it will only distribute to these two beams. So how they distribute? They distribute only half. Means this 6 meter, 3 meter, the half here, 3 meter will distribute to here. Another half, the 3 meter will distribute to the top. Understand? Separuh dia pergi kat yang beam satu lagi, separuh dia pergi beam satu lagi.
Faham doktor?
Okay? So one way slab mean half. One way when you distribute one way slab is easy. Half to here, half to here. One side half, one side half. Because it's not continual 4 edges. It's only distribute to 2 edges, as same as this. Okay? So this unit is wrong, Please help me to correct it. It's supposed to be meter only. So it's 14.25 kilonewton per meter. When you print it out, you make sure you correct it. Okay? So the total GK. The total GK means the total permanent action is the self weight, okay, of the beam plus the brick wall plus the slab. This is the self weight of beam, the brick wall, and the slab, all in kilonewton per meter, means nothing wrong. Okay, make sure when you distribute the load from the slab to beam, you need to get the correct value. You don't take this 4.75 kilonewton per meter square, because this is the load on the slab. But from the slab to the beam, you need to times the value of, if it is one way, then you times half of the length lah. But if not, you need to use the 9 cases. In example 2, 3.2, I will show you. Okay, so total GK is 29.025 kilonewton per meter. Then the total variable actions, okay, Ly is Ly over 2, okay, means half. You take half from the slab. So just now in this example, it's already mentions 4.0 for the variable action. It is provided, right? If not provided, then you need to refer to the table that just now I mentioned to you. You need to check the area, and then they will have the QK value, right? Remember that table? We will have the A, B, C, the few A, B, C, D, E, according to the usage of that slab, that building. Okay, so you need to check. So now the variable action is Ly over 2, because it's taking half, because it's one way. This is for one way, yeah, because W is 1 over 2 N Ly. So this is, okay, W and the Ly over 2 is 1 over 2 N L, 1 over 2 Ly is this. This is Ly over 2 times the N. N is the value from the QK, 4. So you get 12. So what you get here, after you get the QK and GK, you draw the slab, you draw the beam. So the beam and meter beam, you will have the uniform distributed load QK and GK 29.025 plus 12. Okay, this is it, the GK and QK. But then this one, you'll not calculate the 1.3 and 1.5 KK and GK. That one is another, next week you are going to have it. Okay, that one is the load envelope, loading envelope lah. Okay, so this is the GK and QK on it. Okay, everyone, you okay with the example 1? Any question for this example? This is one way example. One way is easy. Okay, let me give you some idea. So first you need to calculate the slab self weight, and then you convert it to become the kilonewton per meter for distribute to the beam. And then you also have the variable actions. Okay, variable actions distribute to the beam, and then you will have the beam self weight and brick wall on it. Okay, so slab, if on the slab you will have slab self weight, finishes, and variable actions. And then on beam you will have brick wall, if you have brick wall on it, brick wall, self weight, and also the slab self weight, and also the variable action. Okay, everyone okay with it? Still okay?
Okay, Doctor.
So I will go to next example. Is it okay? Or you need to take 5? I give you 5 minutes, you take 5, then we go to this example.
Oh, okay, Doctor.
Okay, you take some time digest the example, because normally if in the classroom I will ask you to calculate it and write it, but now no, cannot, it's online. I give you 5 minutes to rest a bit. I need to drink some water also. Okay, sorry guys, I'm being signed out. Alright, so let me continue again. So this is another example. So today we will only have until this example and next example, then you need to do the tutorial. So I believe you already saw in the Google Classroom for today's tutorial, right?
Yes, betul.
Okay, so we go to this example. I don't want to use the PowerPoint already. Keep hanging my computer. So I'm using the PDF. So you determine the characteristic, permanent, and variable action on beam B13. So you need to double check which beam you need to use. Okay. So beam B13 is this B and 1 to 3. So you need to calculate for this beam. Okay. So given the following data, the unit weight of concrete is 25 kilonewton per meter cube. Finishes and ceiling services is 2.0 kilonewton per meter cube. And variable actions of all slabs are 3.0 kilonewton per meter cube. So what you have now here is the beam size, B and H, the length, all the unit weight, the finishes. So you need to calculate the loading. Okay? So what I like to do is the manual one. Okay, so first you need to determine which is Ly, which is Lx. So for this one, okay, so for this you will have Fs1, Fs2, and Fs3. So for calculation, you need to divide by 3 area of slab. Okay, so you will have 3 area of slab. 3 area of slab. So for the first one, here is the Ly. The longer span, remember, the longer span is the Ly. The shorter span is the Lx. So normally what I will do is I will determine which one is Ly and Lx first. So I mark for this, here is Ly, here is Lx. So for Fx2, this is 4,000 and this is 3,000. Automatically here is Ly, here is Lx. And for Fx3, for this is 450, this is 4,500, this is 4,000 mm. So automatically here is Ly and Lx. Why you need to do this? Because remember when we want to use the table 1.9 for the case, we need to use the equation is beta Vx for Ly and beta Vy for the Lx. It's 2 different values. Okay, if you get the wrong one, you get the incorrect answer. So, okay, the load that you will have to distribute is like this. Okay, so Fs1, W1 is 0.5 and Lx. So you get the value, you will get only half because half it will distribute to B13. Another half of the slab loading will distribute to A13. For one way slab is 0.5. Okay, so for W2, Lx, you know the value is the Lx value. This is the Lx value. Okay, so for this, okay, for this part, because here you need to calculate the slab. This is 2 different slabs. So you need to calculate slab according to this area, slab according to this area. You cannot combine Fs2 and Fs3 as one area because here you have a beam. Cannot. Okay. So here you will distribute. As I said, you already determined this is Lx. So Lx for the equation is Vby. You're using the Vy times N times Lx. Okay. And then so this is Bvx times N times Lx for the Ly. They're using OU Lx, but then this is Vbx, this is Vby. Okay. I explained to you now, but you need to do your own revision, guys. So, okay, I wrote it here. So first, I will calculate the action on slab because you need to calculate the slab action first, and then you distribute to the beam. So for the self weight, okay, for the self weight on the slab is 0.5, the thickness. times the unit weight of concrete, then you get 3.75 kilonewton per meter square. Finishes, ceiling and services is 2.0 given, provided. So total GK is self-weight plus finishes, ceiling and services, which is 5.75 kilonewton per meter square. And QK is 3.0 kilonewton per meter square. This is provided. Okay, so also you need to calculate the distribution actions. So FS1 is 3, okay, Ly over Lx is 3, so it's 1 wet slab. FS2 is 1.33, means it's 2 wet slab. FS3 is 1.125, means it's 2 wet slab. So this value later you need to use it to refer to the case 1, 2, 3, 4, 5, 8 in the case, and then they have 0 to 1.0 to 1 point something, right? So this is the value you need to use. Okay, so we go to next. So action from the slab. Okay, so just now the first step you calculate is the action on the slab. So now you need to take the action from the slab, transfer to the beam. So you need to times 0.5 and Lx. Okay, 0.5 times the value of the n, you calculated 5.75, okay, for the GK, and times the Lx. Lx is 2.5 meter. So you will get 7.19 kilonewton per meter. Okay? And then 0, why they are 2? Oh, and then this is GK, then there is QK. QK is 0.5 times the QK 3 times 2.5, then you get 3.75 kilonewton per meter. So this is the GK and QK for F1, FS1, the slab number 1. Okay, so for slab number 2, I zoom it a bit. Okay, so for slab number 2, you need to use beta Vy times n times Lx. So for FS2, Ly over Lx is 1.33. So you refer to the table 3.15 that I show you. Okay, it's 2 adjacent edges discontinue. Because you can see at the slab here. Okay, here is discontinue, right? No slab here. And no slab here. So it's 2 adjacent edges discontinue. So you can go to the table 3.15. I cannot show you now because I want to show you here. You can reopen yourself at the table 3.15. You find it. Is it the same value? Okay, from table 3.15, 2 adjacent edges discontinue. Can you guys follow me to find it? 2 adjacent edges discontinue. So it's at case 1, 2, 3, 4. It's case number 4. Okay? But then the edges, now we are at the continuous edges, right? In the table, they have continue and discontinue. Let me open that. Okay, so you have case 4, you have continue edges and discontinue edges, right? Everyone, can you see this? Ada kan?
Ada.
Ada.
Okay, so do you get the room 1 also? Okay, so you need to get the VBY, but then for the VBY, so you need to go to here. VBY is either 0.4 or 0.26, right? Here you have 2 values, right? One for the continuous edge, one for the discontinuous edge. 0.4 and 0.26. You see this? So you need to get the 0.4 because we are at the continuous edge. The slab here is the slab here you want to calculate is for this continuous edge. So that's why you get the case for 2 adjacent edges discontinue, and then we pick the VBY for the continuous. That's why it's 0.4. Okay, so first you get this 0.4. This one you need to be extra careful because many students got the wrong answer here. So you get the 0.4 for the VBY times the N. N is the 5.75. Okay, that you calculated in the previous slide that you can do your own revision. You will be more clear with it. Okay, times the LX. LX is 3 meter. So you get 6.9. And then the QK also the same, 0.4 times 3 times 3.0. So you get 3.6. So now also you settle for the FS2. Okay. Can I continue the FS3? So for the FS3, okay, is now you are using WVX, not WVY, okay? Because you need to depends on the LY or LX you need to get, right? So here is formula for beam at LY, VVY times N times LX. So here I like to do this by using my own handwriting, even is my handwriting is not very beautiful. I hope you're okay with my very bad handwriting. Okay. So at the LY, you're using this. So from table 3.5, FS3, LY over LX is 1.125. Okay, you need to use a cross multiply. So we go to the table, again, it is two edges discontinue, right? And then it is at the 1.125, in between 1.1 and 1.2. Okay, you can go to this, case number 4. Okay, you can see this case number 4. Okay, it is not 1.1 and it is not 1.2, but it is 1.125. So you need to use the cross multiply the interpolation. You need to get the value in between. So we are using the continuous edges because we are used for the edge at the continuous with the other slab. So it's either this is the value in between the okay. So it is in between 1.1 and 1.2. So it's 0.44 and 0.47. So you use the cross multiply method, you calculate it, you do your own revision. I don't want to explain this. This is the mathematics. So you get x equal to 0.45. So your value for VBUX is 0.45. You substitute the value of N and LX into it, then you will get the GK and QK for the value. So now you settle all the slab. All slab done, Okay. So the load that you want to distribute the beam already done, right? From the slab. You close case for the slab. So now we focus on the beam. So the beam self weight is the width times the thickness. Thickness now 0.5 minus 0.15. Because of what? For this example, it is why is it like this? Wait, let me merge it. Okay, so for this example, example 2, okay, the given value is together with the slab. The 500 is merged with the slab because it's continuous, it's suspended slab. Okay, that's why the value of hash, you need to divide the thickness of slab. Okay, here I put minus slab thickness. So the question, when you get the questions or design, you need to be extra careful. Either it's rectangular beam, or it is French beam, or it is beam with precast. Double check, it's important here. And then times the unit weight, then you get the beam self weight. Okay. And then you need to get the load from the slab. Okay, slab. So permanent action on span 1, 2, and span 2, 3. You have for this example you have 2 span, right? You have span 1, 2, and span 2, 3. For span 1, 2, you will get the load from this slab FS1 and this FS2. For this span 2, 3, you will get the load from span FS1 and span FS3. It's 2 different loading. Because at this section, you will not get the load from FS3. For these sections, you will not get the load from FS2. So when you calculate the load from the distribution of the slab, you need to separate to 2 span. Okay, so for span 1, 2, you will get the permanent action from FS1, FS2, and the beam self weight. Okay, FBS is stand for the beam self weight. It's not stand for another backwards. So you get 15.84. Okay, you can directly take the value of this because this is all kilonewton per meter, mean per meter length, means uniform distributed load on that beam. per meter length. So later when you want to calculate on the calculate the load on the beam support, then you can use it. That's why you directly take it, because it's uniform distributed load on that beam per meter length. Okay, that one supposedly you can digest it. You can think it. I cannot explain it longer. It will take another half an hour. Okay, so for the QK, it is from the FS1 and FS2, no self weight, because the variable actions are from the slab to the beam to the column. Basically, are only one. Sorry. So QK is basically only from the slab, no self weight. Okay. So 3.75 from the FS1 and 3.6 from the FS2, you total up, you become 7.35 kilonewton per meter. Okay. And then for the span 2, 3, you will get the load from the FS1, FS3, and the beam self weight. So you total up, you get the GK, and total up, you get the QK. So both value you plot into the free body diagram of a beam. Okay, this is span 1, 2, span 2, 3. So you will calculate, you will get GK and QK, GK and QK for the value. Okay, so you can total it up, then you can calculate. Okay, so I think case 2 is only until here only. So for chapter 3, you will calculate the load actions. Okay, so this is another example. Okay, can I go to this example? This is short. After this finish, then I will let you go from this class. You already accept a lot of things, including the preliminary size and this. So you need time to practice and accept it. Okay, a series of 250 times 450 reinforced concrete beams span at 3 meter centers and spanning 7.5 meter support at 175 mm thickness reinforced concrete slab as shown. Okay, the variable is 3 kilonewton and the unit weight is 25, the maximum shear force and bending moment. For the tutorial I give you is until shear force and bending moment. So this example is similar. Again, you will need to calculate the slab and the beam. Okay, so after you calculate everything, you will total it up and draw like this, right? The W, total W is how much? Okay, so the W, you will get the total load is 1.35 GK plus 1.5 QK. Okay, so this is the ultimate load. You remember first now you're using the total ultimate load is 1.35 GK plus 1.5 QK. That one I think in the chapter 1 we have mentioned this before. But in next week we will go for the load envelope, then you will have the more cases. So this 1.5 GK and 1.5 QK, after you just now you get that value for this one, right? For example 3.2, this is not the final one. You need to times the 1.5 GK plus 1.3. I lost my voice here. Okay, you need to times the 1.35 GK plus 1.5 QK. Okay, and this is 1.35 GK plus 1.5 QK. Then you will get this maximum W, ultimate load. So from this ultimate load, okay, you will calculate the maximum shear force and maximum bending moment diagram. So for example 3.3, I want you to digest it so you can do your tutorial. Okay? Yes, from the slab. Okay? So any questions? You need time to digest, huh? So go back home, you can do that tutorial. The tutorial, let me open it. My internet is not okay again. For the quiz, I think last time there are few students didn't submit yet. If you not yet submit, please submit it. Once I want to mark, then if you not submit, then I will not give you marks. For the tutorial of today, open this. Okay. So you need the Q1 provided the ground floor plan of a reinforced concrete office building slab thickness. dimension of the bins given. Okay, and then they give you all the data given the additional followings, or they provided this, or analyze the beam, the design action carried by the beam 1, 2. So you need to calculate the beam B1, 2 and sketch the action distribution for each slab. Calculate and sketch the bending moment and shear force diagram for B1, 2. So you need to do this lah. Okay, so you do this and then next week we discuss. You can submit first. Okay, then we will discuss on it. Then we will continue again next week. So any questions for today? I think you need time to digest it. Go back, practice it. You have all this slide you can practice and then you try to study it again. Any questions?
No, doctor.
Okay, so today you study until chapter 1, you only study until example 3.3 lah. For the handout is also including the example 3.4. This one is for next week. Okay. So also you can go on the videos that I prepared for this class recorded video. I will post it in the YouTube and then give you the link later on. So everyone have a nice day today. So just today everyone is coming, right? Just now who not yet take the attendance, you can stay behind and let me check. Those already take attendance, you can leave the class if you have no questions.
Test 1.
7 May.
7 May. Got
Is-
chapter
yes.
berapa?
1, 2, 3.
1, 2, 3. Oh.
Hmm.
Including design the slab and beam.
Not design, but we calculate the load.
Calculate the load. Okay.
Yeah. So it's basically until what you learned today.
Oh, okay.
Okay.
You need to do from the architecture drawing to structural drawing, and also you need to calculate the loading actions.
Thank you, Doctor.
Okay. My computer is hanging again, but I think everyone is coming today, so I will take the attendance for everyone. My computer is really protest. Every time in the class doing this to me. Yeah. Okay, so see you guys again. You can quit the class. My Google Meet is not responding, so I cannot see you guys leaving or what.
Okay.
All right, thank you, doctor.
Bye.
Thank you, doctor.
Okay, thank you, doctor.
Thank you, doctor.
Bye-bye. Bye.
Thank you, Doctor. Have a nice day.
Yeah, I have another class at noon. Bye-bye.